Okay. Welcome again to our video on proving. Okay, but this time we are going to prove a statement by using mathematical induction. For example, this statement here where it involves inequality, that is 3 to the power n less than n plus 1 factorial for n greater than or equal to 4. Okay, so let's prove this by using mathematical induction. But before we do that, let's say that our PK, PK is a statement, represent this statement, that is 3 to the power k less than k plus 1 factorial for k greater than or equal to 4. Okay, this is our PK. Okay, now for step number one, right? Now we have to ask ourselves, what is the smallest value of integer in this interval? Okay, for k greater than or equal to 4. What would be the smallest value of k? Yeah, of course, k equal to 4. So let's find out what is the value of P4. Okay, with k equal to 4. Okay, we would like to check the value of P4 for left and right hand side. So first what we have to do is for left hand side first. What is P4 is equal to what? Okay, whenever we see k, we set it to 4. So 3 to the power 4 is equal to 81. Now for right hand side, what is P4? Equal to 4 plus 1 factorial. This is equal to 5 factorial. This is equal to 120. Now let's check. Alright, the left hand side we have 81. The right hand side is 120. Is this statement true? Is 120 is greater than 81? Or 81 is less than 120? Yes? Yeah, this is true. So P4 is true. Okay? For step 1, this is what we have to check. Okay, let's continue with our proving. Now we reach at step number 2, where we have to assume PK is true, and we have to show that P of k plus 1 is true. That is, we have to show that is pk plus 1. Pk plus 1. Okay. That is 3 to the power k plus 1 less than. Okay. Whenever we see k, we replace by k plus 1. So k plus 1 plus 1. So we have k plus 2 factorial for k greater than or equal to 4. This is what we have to show. That is 3 to the power k plus 1 is less than k plus 2 factorial. Okay, so let's start with the left hand side. That is 3 to the power k plus 1. Now we can break this term down as 3 to the power k multiplied by 3 to the power 1, right? Or equal to 3. Or this is can also be written as 3 multiplied by 3 to the power k. Okay, we change the position of 3 and 3 to the power k. Now, from our assumption, okay, since we assume pk is true, thus this statement is true. That is 3 to the power k less than k plus 1 factorial. Now, whenever we see 3 to the power k here, we are going to replace by k plus 1. Now, this equality will be will change to inequality like this. So 3 multiplied by 3 to the power k, okay, all right, so this will be less than 3 multiplied by k, okay, plus 1 factorial. All right, so, and this term is less than k plus 2 multiplied by k plus 1 factorial. Now, how can I see that? Okay, how can I say k plus 2 multiplied by k plus 1 factorial is greater than 3 multiplied by k plus 1 factorial? Now, if we still remember, k is greater than or equal to 4. Okay, what I mean is the smallest value of k is equal to 4. So if we substitute k equal to 4 here, k plus 2, that is 4 plus 2 is 6. So 6 multiplied by k plus 1 factorial is greater than, of course, greater than 3 multiplied by k, okay, plus 1 factorial. And this term here, that is k plus 2 multiplied by k plus 1 factorial, that is equal to k plus 2 factorial. Okay, how I get from here to, from this step to this step? I think you have to think about that. All right, so we have 3 to the power k plus 1 on the left hand side, that is this term, is less than, okay, k plus 2 factorial, okay, for k greater than or equal to 4. This is exactly what we have to show, this statement. All right, k 3 to the power k plus 1 is less than k plus 2 factorial. Right, this is the statement that we have to show, and we have shown it. Therefore, p of k plus 1 is true. All right, thus we have proof. Okay, we have proof that, all right, we have proof that 3 to the power n is always less than n plus 1 factorial, okay, specifically for n greater than or equal to 4. So our our proof is complete.